Welcome everyone to our last session of Map Time Davis for this quarter. We will be back next quarter with more workshops. We've actually got a fairly large slate for next quarter, so we're excited about that. Stay tuned for more details coming out on the geospatial list. So again, welcome everyone. My name is Michele Tobias. I am the geospatial person in Data Lab. I don't know what my official title is. And I am one of the founders of Map Time Davis, but I am putting this on with the help of a heck of a lot of people who we call Map Time Davis Council. And we are going to be looking for new council members soon. So look for an announcement coming out sort of first or second week of next quarter on the geospatial list if you'd like to help organize this. I'm just going to plug that right now. Today, we are going to be talking about photogrammetry. And some of you, when you signed up, you may have signed up and saw that Clancy McConnell was going to be talking today. But Clancy had something come up, so me and Liam are going to be filling in instead, but it's still going to be a photogrammetry workshop. So let me share my screen. I am going to be working off of these materials. Let me just other stuff. So this was sort of a short turnaround getting this together. So I apologize for not having super exciting slides to share today, but workshop. I think I'll try to remember to stop and show you some pictures as we go. So photogrammetry, what is this thing? It kind of sounds super fancy. It kind of sounds super academic. I could make this, I think it's as good as I can. But really what photogrammetry is just ASPRS, which is an academic organization for people who do remote sensing and photogrammetry. They have this statement on their website. Photogrammetry is the art, science, and technology of obtaining reliable information about physical objects and the environment through the process of recording, measuring, and interpreting images, patterns, electromagnetic, radiant energy, and other phenomena. Oh, that sounds sounds really fancy and also really hard. But really what photogrammetry is just learning about objects through photographs or similar data collection. So often we call that process remote sensing. So we're finding out things about something without being near it. So it's remote, it's far away, and we're sensing it. So we're seeing it, we're interpreting it. So essentially, you are doing this process every time you open up Instagram, you open up social media, and you're looking at pictures. In some respect, you're doing photogrammetry. You're collecting information, you're understanding things about something that's far away, processes. So it's really not that as much as it seems like, oh, this is a big scary word. And it's also not really that fancy. It's something we actually do as humans all the time. Of course, how we make scientific measurements with these kinds of photographs and similar kinds of data is a little bit more complicated and often involves a lot of geometry, but you know, we're fortunate that a lot of times there are already pre-programmed tools that can help us with that. So while occasionally, if you flip through some of my research notebooks, you will see a lot of geometry. Most of the time we don't need it. That's mostly me trying to figure out what scale my airflows that I take. So, and also in the grand scheme of things, photogrammetry really isn't that old, even though the name might sound like something that's very academic. And you can imagine people in the 1700s in their robes walking around having photogrammetry classes. It's really only as old as photography, right? Like this is based on mostly on the concept of photography. So it's really not that old. And actually a lot of the stuff that's going on right now with photogrammetry is really cutting edge. When you watch the news lately, a lot of times you're presented with these satellite pictures from Maxar. It's all over the place. Like these people are doing photogrammetry. It's really helpful for conflicts that are going on right now. It's helpful for understanding shipping patterns. There's a lot of stuff out there that's photogrammetry, but not public. So just know that this is something that's been around for a long time, but not that long. in the grand scheme of human history, it's actually something that we're doing a lot of these days. We just aren't calling it by technical term. We're calling it other things. So today's workshop, my goal is a little bit different, I think, than what Clancy's original plan was for his workshop. What we're going to be doing today is really understanding a broad understanding of the workflow that we'll be using in the concept of photogrammetry and processing. So I think as somebody who works with researchers a lot, I see people coming into office hours. They've already decided they want to work with drones because drones are cool, and drones are cool. But what they haven't thought about is all of the things, the steps that they should have looked at before they got started, before they decided that drones was the thing to do. We're going to take a step back and start at the beginning, help you figure out that, like, what platform do you even need? What kind of questions are you going to be wanting to answer, and how do you solve that?
You want to make it bigger, thing just to the left of files.
Oh, I didn't know that. Cool. Learned something in my own workshop. Also, a quick note before we dive in too much further. My experience is terrestrial remote sensing. You can do remote sensing and photogrammetry, not of the Earth. For example, you can do this with Mars, and we do this with Mars. You can also do this underwater and in other situations. So most of my examples, also the assumptions I'm going to make are going to be that we're talking about flying in the air and we're looking down at the Earth. But you can do similar processes in other ecosystems, in particular underwater. You want to do this in an ocean or a river or a lake, you can, but there's just slightly different tools. Like drones aren't going to work, but you can do this. Okay, so we've got, this will probably show up better for folks using their own web browser, not having to zoom in so far, but I've got a quick diagram of our workflow today. So we're going to start thinking about a research question. Once we do that, we can start thinking about getting images. Following that is when we start doing our image processing, and then finally our interpretation of that step. So pretty high level concepts today. We're not going to dive in too deep on anything in particular unless folks have questions that I or Liam can answer. You're certainly welcome to ask us in-depth questions about our areas of expertise, and we can try to do our best to answer things that are outside of our immediate area of expertise. We'll do the rest. Okay, so first thing you need to do before you do anything else, before you decide that drones are the coolest thing in the world, that's what you're going to use to research. What question do you want to answer? For researchers, this is the key to all of this. Every single thing we do after this point is going to be driven by our research question. So what question do you want to answer? For folks online, if you have a research question that you're working with, feel free to drop that in the chat. Those of us in the room will be able to see that. And then for folks in the room, does anybody have a research question that they're working with right now that they might want to share? Yeah.
So Liam's aware of what I've been interested in. I would like to develop fine scale vegetation maps at plant species level for an area of 125 acres in size.
Okay, great. So for folks on Zoom, I think that my mic is picking up the room, but in case people didn't hear, the idea was to develop fine scale vegetation maps for an area that's at 125 acres in size. All right, so that's a great thing to be able to do. I saw everyone else looking terrified in the room. Don't pick on me, don't call on me, so I won't. For me, I use my big question that I use this kind of work is I'm trying to understand the distribution of California's sandy vegetation. So I have to do that by, I will tell you, after having done many insect surveys on California beaches, doesn't work as well to do transects as it is to have pictures. So that's my research question, just to give you an idea of what you could be doing to start with. So I'm working at the scale of individual beaches. Okay, so once you have your question, now we want to start thinking about some details about this question. In particular, these are the kinds of things you need to know, be able to pick out what kind of imagery. One thing you want to think about is, what is your geographic area? You know, what location are you looking at? How big is it? Where is it located? What kind of environment is it? Also think about the scale. So for example, like I'm interested in a fairly small area. Beaches in California are not that big. If you're looking at potentially scale phenomena, like are you interested in entire forests? Are you interested in doing something with the entire state? Or maybe it's a global question. That's going to change what imagery, what data you need. So you want to think about that geographic scale. So how large are the objects you're trying to detect? I'm one of those silly people who's like, I really want pictures of plants that are about this big. They're small. If I could see even smaller ones, I would be even happier. But that means I can't use certain data sets because a 30 meter by 30 meter pixel from Landsat is utterly useless to detect something the size of my water bottle. Like I can put 1 million of those inside of a 30 by 30 meter pixel. That's huge compared to the objects I'm trying to detect. So that scale of the thing I'm trying to see in the imagery really helps me understand what photography or what data sets are going to use. Also your time scale. You're only interested in one point in time. Maybe you just need a snapshot, you know, of what's going on today. So if that's all I care about, I just need one data set or one set of data from one day in the whole possibility of options. Maybe I'm interested in something going on for over the course of the year. We know something's happening that's important and we want to track it over a certain time period. Maybe it's cyclical. Maybe the thing I'm interested in, because I'm a beach geographer, I'm going to keep coming back to this. Beaches rebuild every year and then they erode every year. So the time scale I might be interested in is yearly, but I'm going to be restricted to only a beach stable period if I'm interested in beach size. If I want to be able to see that cyclical change in the beach getting smaller and wider, I'm going to need to change when. Instead of just summer, I'm going to want to do maybe monthly instead of one time one season. Related to that is how often you need images. What time are we going to start and end? So is this something you want to do? Like I've done a project where we're looking at beach change from the 1920s through current day. So that tells me what my time period is. What time of day? So you can do, like mostly I exclusively work during the daytime because things I want to see are only able for us to be seen on the daytime because they're plants in a place that's not well lit. But if I'm interested in understanding how light changes over time or the distribution of lights coming from cities, I'm going to need to do that at night. So time of day can matter. Also, maybe if you're trying to detect something that only happens at night, like maybe you're trying to detect a species that is nocturnal, for example, you might want to be taking pictures in the nighttime. That's also going to change what wavelengths you use. So visible light, not so available when it's night. So you might need to collect different wavelengths. You also might need an active sensor instead of a passive sensor. So you might be needing to put out like infrared light that bounces off the thing you're trying to see if it's nighttime. If you're working with plants, for example, you probably need infrared, depending on what your question is and what you're trying to detect, because plants are a little easier to see in infrared, turns out. They're easier to detect and differentiate between other things that are just green because they're green, like green paint. So green paint will reflect very differently than a plant, which reflects really well in IR. And one final thing to think about is budget. So do you need to pay for the data that you are going to be working with? How much will that cost? Are there free options that you could? These are all things to think about and plan for. Also, you know, if you're going to be collecting your own data through like drones or kites, you know, how much is it going to cost to build that platform? Are there travel costs? Because sometimes we forget that, you know, unless we're working on a very local scale, close to our house, close to our place of work, we're going to have to probably travel to see the things that we're interested in. So factor that in as well. Okay, so hopefully you're not super overwhelmed. Just think of this as kind of a list to dig into, and you can refine it over time. You may find that what you know, your ideal situation is not available, but can you adjust? So being flexible can be really. But just think about these things. It's not just a matter of like, well, I just want to work with this imagery, so I'm going to work with it. It may not solve your problem. Would love to be able to use the commercial satellite companies that manage the planet daily or weekly. We use those data sets. Size is just not going to work. Even at 5 meters, it's big for my system. So, I mean, not the end of the world to have to go to the beach and take our own photos, but it'd be a heck of a lot easier to not have to do that and just do it. There's a lot of work to go collect your own data. Okay, so now we're ready. We've answered our research question. We've thought about kinds of parameters we're going to need our imagery useful for our question that we're going to answer. Now we're going to think about our images. How are we going to get these? So you need to think about, you know, what data set is going to fit your need and help you answer your question. So really you want to think about all of the things we talked about in step 1 and start trying to match up what's available for imagery or what kind of imagery you need to create in order to answer your question. So if you are an academic, now is a really good time to do your literature review. I recommend this a lot. The office hours that really need to spend some time early on thinking about, you know, what have other people done? And not just because you need it for your publication, but also because you're going to get some really good ideas from people. You're going to see what worked, you're going to see what didn't work, and you'll be able to build on you know, what other folks have done. You don't necessarily have to design a whole new system. You might be able to work off of somebody else's ideas and kind of use it as a draft that you can build on, which is what we want to do in academia, really. I think that's important, but also it will save you a lot of time and headache, and you want to know if someone else has already studied your system, the remote sensing system you're planning, because spent a lot of time finding out someone's already published what you were planning. So again, like there's a lot of reasons to do your literature, but about, you know, between step 1 and step 2 is a really good time to do that. It doesn't also see all of the things people have tried. So typically when we're thinking about data sets, we kind of can categorize them into 2 options. One is using an existing data set, and one is collecting your own data. So existing data sets have some advantages. One of the things that is really powerful about using data that already has been created is that this is pretty much the only way you can get data from the past. So if I need to go back and understand what happened in the 1970s in a place, I'm going to be looking for either things like air photo collection, something, you know, somebody took air photos of my area of interest back in the 1970s, or satellite imagery from that time. So that's pretty much the only way we can get historical data, is these data sets that already exist. We can't, as far as I know, we can't go back in a time machine and be like, oh, now I want to go see what happened yesterday. I just can't do it. Like maybe that seems obvious, but I can't collect drone imagery 2 days ago because I didn't collect drone imagery 2 days ago. I can't go back if I didn't already do it. Some disadvantages with existing data sets is that you have to work with somebody else already did. Whether that was you collecting data, you know, at another point in time, or a government agency, can't change, the imagery that has been made. It is what it is. So one thing to keep in mind along those lines is things like available technology. So all of our technology is changing constantly. What we're capable of doing now is very different than what we could even do 10 years ago. One thing that I think people are starting to forget is that color photography was not always a thing. Color photography didn't always exist. I think those of us who were born in the digital age, we tend to forget that the world was a little bit different previously. So color photography has been around since like the mid to late 1800s. It really wasn't available commercially and widely until the Kodachrome system in 1935. So even then, I still wouldn't expect to see air photos in color in the 1930s. I would not expect to see that happening until like maybe the 1970s, maybe early, but it really was not as available as we might think. So keep that in mind. Technology changes. There is still photography available then, but it's probably going to be something we call panchromatic. Black and white, collecting visible light spectrums, but it's turning that into a black and white image. So you work with that differently than you would color photography. Also, film photography is going to be different than digital. So be aware that this might surprise people. People used to do photography on film and then make prints. So that doesn't come in a native digital format. That's something you have to convert. So just be aware of that. There's going to be different, the further back you go, the more different systems you're going to have to understand and how to work with different technologies and different data and what the advantages and disadvantages are. The cool thing is, especially when you work with older technologies, you get to learn a lot about how these technologies have developed. And some of the things that we used to do for print photography is, for me, it's super exciting to see, and it's amazing to see what we can do with that kind of photography. Living in a digital age, it's there's a lot you can do, and it makes me really happy. Then again, take me in the map room and open up the air photo drawers, and I will just stay there for days. So if you're interested in finding aerial photography collections, especially historic ones, UC Davis actually has a really nice collection for the Central Valley and agricultural topics. If you're looking for other areas and other subject matter, other UCs collect different data sets, different air photo types. So you might need to go to a different UC's collection depending on what you're interested in, but definitely library folks can help you figure that out and help you access what you need. Also, different government agencies often hold air photos for areas of interest. I used to work at state parks, and they have a big cabinet full of air photos of different parks. And also, obviously, certain government agencies will put other air photo collections online, like can access the USGS, various USGS sites, the native imagery, for example. So there are a lot of places you can get aerial photography from. And this is a really nice way to get historical data. Another existing data set that's pretty common to use is satellite imagery. This generally goes back to about the mid-70s. There were projects in the 1940s and things like that, but those are less available or more limited in like geographic scope. So I'm really not sure where to find those other satellite data sets, but they probably exist. We just have to figure out what to find them. Also be aware that, again, technology changes over time. So earlier satellites don't have the spectral capability that we have now. We have, like, if you look at the current Landsat satellites, they have a lot more bands available than they used to when Landsat started. And that's normal, but it's something to be aware of, that you may not be able to get the same bands that you have now further back in history, depending on what sensors and what platform you're getting the data. Also, satellites tend to be a more coarser geographic scale than like air photos or drone or kite images, just by nature of what they're trying to capture. They tend to have bigger pixels. So So it's great for broader geographic scales. For me, it's less useful for the tiny, tiny plants I want pictures of. So keep that in mind, that that is helpful, but if it doesn't meet your needs, you will be spending a lot of time downloading stuff that you don't necessarily be able to work with. So think about what you need. Yes, I will only do satellite imagery. Might not work depending on what you're looking for. One other thing to keep in mind in terms of existing data, you need to go back even further in time. You might want to be starting to look at historical maps. Obviously, like maps, are aware, have the bias of the person or the created them. They're created for a purpose. Topo maps supposed to be showing topography and elevation, and they tend to focus on natural things and also infrastructure. So they show things like roads. Sometimes they show buildings, but really they're showing a lot of lines for elevation and like where natural things are, where the rivers, where the coastline. They might outline like, the boundaries of national forests and things like that. So if you're interested in other phenomena, you may have to find a different source for that. But if you're trying to piece together a really long history, you might include other sources of information. So those were all the things that are sort of existing data sets are, like air photos, satellite imagery, and potentially maps. Now you can collect your own data. And I would say collecting your own data has its biggest advantage when you're working with a fairly small area. So when we're talking about platforms like drones, and I do kite aerial photography, moon aerial photography, these types of systems are really geared more towards covering smaller geographic areas. So I probably wouldn't use a drone to try to image the entire county. It's going to take, not only will it take forever, spend a lot of batteries, you're probably going to wear your drone out trying to do that. And it's also going to be a ton of data to have to deal with, a lot of images for the entire county. So generally drones and kites and things like that are better for places, for questions where you need lower altitude imagery and also a smaller area, just because of the nature of the platform, the thing that's carrying the sensor. And I will point you to our YouTube channel for Naptime data. I have folks on YouTube that are watching this after the fact. We've done, last year, we did a couple workshops on using drones and also using photography. So check those out. That's one reason we're not going to go into a ton of detail today on those systems. Just did workshops, and we think that videos are still current enough that you can watch those. One of the big advantages of collecting your own data is that in theory, you are in control. You decide when and where, how high to fly. You get to decide what sensors go on this platform. But in practicality, obviously, you're going to be dealing with some limitations, in particular budget, for one. Adding more sensors probably costs more money, and all like also you have payload issues. Like you can only put so much weight on these things, otherwise they won't fly. Also, weather considerations and things like that will keep you from flying maybe on the exact day you want. But in theory, you are in control when you're doing this. And also, I will say there is nothing as exciting as seeing the photos that just came out of your aerial photography system. You're standing in the parking lot, flipping through your camera and being like, oh my goodness, I can't believe what we got on camera. I'll show you some pictures of a recent photography trip in a second. It's super fun. There's no denying that. So add that to your reasons why you might want to do this. But there's also some disadvantages, and this is, I have in my information, like this is where we start getting serious. You're going out in the field, right? So you're going to the place you're trying to get information from. You have to physically be there. This is field work. It can be dangerous. We're dealing with, drones have blades that are spinning around. You can get hurt with those. With kites, they seem super friendly and like mine are rainbow and pretty colors. Fuzzy tail for one of my kites is quite fluffy. So you might think, oh, there's no problem with this. a line under tension, it could actually decapitate you. So I know, that's why I said we're getting serious. Like a line under tension is a real serious thing. It can be like a knife. So you want to be careful. You need to recognize what harms can happen. And, you know, you want to plan for being safe. You want to know what those potential things could be so that you can avoid them. So it's not necessarily all fun and games. If you're doing field work, you need to be ready for all of the physical things that can happen while you are out there collecting data. And also like safety considerations, like things like weather. You're not going to fly a drone or a kite or a balloon when there's thunderstorms coming through. You just don't do that. I work on the coast. Also, this is not related to platforms, but if there's an earthquake, we leave. When you're on the coast, there's always a tsunami risk. So that sounds like kind of like being overprotective, but these are things you need to think about is, you know, how do you be safe where you're going to be? How do you use your platform safely? Because it's not the same as downloading imagery from the USGS or the NASA sites. Those have substantially less personal risk involved than going to a field site and running something with whizzing blades. I just want to be real about that. It's super fun, but you know, you've got to be careful. You have to have safety protocols if you're going to be collecting your own imagery with these kinds of things. You're also restricted by, at least if you're flying in the US, you are restricted by FAA rules, no matter what tool you are flying, whether that's a kite or a balloon or a drone. So you need to know what those are and you need to follow them. It's very important that you are not disrupting air traffic when you are flying something in the air. I will say that tethered systems like balloons and kites have different rules than drones. Can be a little less restrictive because it's not unpiloted, because it's connected to you through a line, but that will also limit what you do because you can't go that high because you have a line. But still, like when I fly, my teams know if you're in an aircraft at all, kite comes down. I don't care how good the imagery is going to be. If we stayed up there, I don't care one bit, because flying on the coast, you often get like advertising planes that fly really low, or helicopters or things like that. So as soon as we hear aircraft, it's coming down. Figure out where we're hearing the aircraft, and then decide, you know, are we just getting sound bouncing off of something? So there are things like that that you need to be. You definitely want to check your FAA maps for where you're allowed to fly. And also, somebody comes and tells you you have to take it down, you take it down. We've flown a couple places that we thought were okay, and then it was, I guess, near enough to an air base that people came and said, take that down. I'm like, okay, that's fine. Listen to the people that have more. So, another thing to think about when you're collecting your own data is, again, you can't do drone imagery from the 70s. Doesn't exist. Drones weren't a thing then. You can't go back in time. So be aware, if you're going to go backwards in time and you didn't collect imagery when you wanted to have imagery from, it doesn't exist. You're going to have to find another solution for that. So when you're collecting your own imagery, I like to think of it either I'm doing it now or I'm doing it in the future. I'm not doing it yesterday. I can't go back in time. So you'll have to fill in those needed data sets with other existing data sets. So plan. Another thing you can do also, you could potentially, if you know you need a certain data, there are still companies that will fly air photos for you. So you could contract with an air photo company to do, you know, small aircraft air photos, or if you need a larger area. That's how we get air photos for the city. Your question, Alex.
No, I was going to add into that. You can also go pay to task a satellite. Some companies let you pay for collecting data over a particular place on a specific day.
Yeah, I was going to mention that too. So for folks online, if you couldn't hear, that you can also sometimes, depending on a satellite system, you can sometimes task a satellite to, when it's flying near where you want to have a photo, they can adjust the way that it looks, like the angle, and make sure that they get the area that you're interested in. So you can pay companies to do that. So that is also an option. But again, that's going to fall into that budget question. Do you have the funds to do that? Keep that in mind. Okay, so Another thing you can do, like I mentioned before, is you can combine existing and new data sets. Like maybe I'm taking my kite aerial photography of a beach I'm interested in with my kite system, but maybe I'm also going to combine that with, some of the smaller geographic scale, like the smaller pixel satellite imagery. Maybe I've got some air photos of the same place over time and things like that. Maybe also I've got some oblique pictures from, even earlier that I can work with to get information from those things. Again, you want to be aware that you're not going to have the same kind of data in those different data sets, but there are ways to combine those depending on what your question is that you could potentially make it work. So I might not be able to identify, plants down to the species level the way I can with my super fine scale imagery, but maybe I can at least tell where the plants are, tell the beach with things like that. I keep coming back to beach examples because that's my research life. At least most of you probably know what a beach is. You may not know that there's supposed to be plants there. Anyway, so combining, I have a table in here of, sort of considerations for different platforms and different sets of information, but you can dig into that and fill in any other details you might want. So once you get your imagery, you figured out whether you're taking your own pictures, you're going to a Landsat archive, you're going to be looking at UCSB's Air Photo Archive or something like that. Now we're going to start the processing. So we've got our data in form of this set of imagery. Now we got to figure out how to work with it. So again, we're going to come back to our question in step one. What is the research question I'm trying to answer? And that's going to help me know what I need to do for processing. There's not like one set of, you get your imagery and then you do this workflow. There's not just one workflow. You kind of have to figure out what you're going to need for your particular set of data. So some possible things you might be doing, things like cropping or masking. So maybe I've got a Landsat image like we did in the stack workshop this quarter. I only care about a beach that's about this big and this giant image. I don't want to process that whole image, so I'm going to crop it down to something smaller. So I don't have to work with all of this mountain area, inland area that doesn't matter for my research question. It's going to make things faster. I'm going to have less things to store. My calculations are going to go quicker if I crop this down and make it a smaller image that only has a pixel size. At the same time, you might have a bunch of photos you've taken over your research site with a drone. Bunch of little pictures, right? And they're all tiled. And it would be really nice if they're all just one image. So we're going to do photo stitching or mosaicing on that to make one big image from all these little photos that we took with the system that we have. The same thing can also happen with satellite data as well. If your research site, of course, ends up, on the seam between two photos or two satellite images, you might have to mosaic two data sets together to get a contiguous data set for the thing you're looking at. You might also want to start doing things like calculating indexes. Again, your literature review is going to help you know if that's going to be helpful for your system, but you might need to do like an NDVI calculation or an NWI calculation like we did in the stack workshop looking at Landsat imagery. So you'll know which bands are interesting for your system from that literature. Is there creative ways you can combine these to help the thing you're trying to find stand out? Also, depending on your data set, if you have things like overlapping air photos or overlapping drone imagery, you might be interested in building a 3D model. It is possible to do that even with historic air photos if there's enough overlap. So you can take images from the 1920s because of the properties of aerial photography, as long as it's not orthorectified. It has to be not messed with, like it can't be processed. If you orthorectify, it don't work. But you have your raw air photos, parallax, the lean of tall objects in the photo. You can use photos that overlap because they have, they'll show different geometries for the thing you're looking at. You can actually pipe that through a 3D model builder, and you can build 3D models even with historic air photos. So it's not just for drones. You can do this with stuff from much earlier, and that's actually how we get topo maps from back then. People would use tools that would let them see things in 3 dimensions, and then they could trace. So that's not all the things you might do for processing, but that's kind of the things that come to mind for me when I'm doing this kind of stuff. Again, you're going to tailor this to your needs for your research question, and that literature review is going to help. Okay. So finally, we have, we know what our research question is, figured out what data we're going to use, and now we've processed our data so that we can use it. Now we're on to the interpretation and measurement stage. So by now we are securely in our offices. We've got a pot of coffee, and we are going to start looking at our photos and start trying to interpret these things and start making measurements. How do you know what to do at this stage? Now, this is the part, this is the huge part. This is where the classes come in. This is why you would take Intro to Remote Sensing, why you would take the air photo interpretation class we have on campus, because this is where you learn the tools that you would need to do this step. If you're not interested in taking formal class, there's some really good textbooks out there. I've got one linked at the bottom of the shop materials that I was looking at that looked really nice. But there's literally thousands of them if you are a part of the University of California that you have access to either in print form at our library or online. There's a lot of good online books now. So take a look at that. Also, again, exploring the academic literature, doing your literature review is going to help you know what is going to be useful for your particular ecosystem that you're working in. It's also a good idea to look at related systems. Like, I'm interested in beaches, but a lot of stuff that's going on in desert ecosystems would be applicable. So I might look at both those places, for example. If you're interested in deciduous forests, you might still be looking at other forest systems, maybe conifers and things like that, to see what methods they're using on those systems, because they're similar in structure, but you might find something useful in a related ecosystem. So what are some of the things you might be doing if you're measuring? And this is a short list. There's a lot of things you could be doing to make your measurements. So one really common thing to do is what we call heads-up digitizing. So you're digitizing boundaries on a photo. Maybe you're outlining plants, maybe you're outlining roads, maybe the edge of a forest, coastline, something like that, river. Then you're digitizing by hand, so you're clicking along. You might want to be doing something like image classification, assign pixels into groups. So, based on the spectral signature that's in each of your pixels, you might decide, okay, that's a tree, that's bare ground, that's grass, that's a road. Classifying those pixels can help answer your question about maybe you're trying to figure out where the trees are and how much tree area there is. And maybe changing it over time as well. You can be doing something like image segmentation where you're trying to find objects. I've seen this done with like boats out on the ocean where they're looking at where shipping lanes are, and you can actually pick out the signature of a shipping vessel crossing across the Pacific Ocean. Don't want to do that by hand, so you might develop an image segmentation algorithm to find those and outline them for you so you can count them and see maybe how they're moving over time. That's the automated tools are particularly helpful when you have a lot of imagery to look through. The Pacific Ocean is very big. Satellite imagery, you probably want something that's going to help you find those rather than doing. Other things you might be doing is, again, adding that change over time component, in some measurement. In particular, might be if you're interested in movement of things, doing change over time is probably how to assess that. But also, there's a lot of reasons why we want to be looking at how things are changing over time, in particular with climate change and things like that. Okay, so I made up some examples at the bottom here, but I think it's more interesting to look at some real examples. Particularly fun picture. This is from gosh, where were we? Santa Cruz, last spring. So this is go over a dune system. I'm just gonna point at things on this screen for the folks in the room. Folks on Zoom, compared to what you're seeing. So like, probably a little bit hard to see on the big screen, but like this is a forging system. So I can tell because there's sand shadow. So you get, the more you get used to looking at your system from above, the more you'll start to interpret and be like, oh, I know what that is on the ground. Like I've seen that in person, like there is a sand dune and I can see that it tends to be round in front and towards the back because of the way the wind blows and moves the sand. That in the where it looks like each of the dunes has like a little light tail coming off. I can tell you what species of plants these are because I'm used to looking at them. But you won't know that until you get familiar with the system. So you want to spend time looking at it. And again, like this looks pretty big on the photo, but it's probably only as wide as maybe 2 of these desks. It's not really that big in the grand scheme of life, so this wouldn't show up as big as it looks on this picture. This does not show up necessarily on a satellite image. So that's why we need close. Other fun things going on in this particular is further this way. This is inland toward the bottom. There's a heck of a lot of poison oak in this picture. This beach had the most poison oak I've ever seen. I ended up washing my backpack for 2 cycles because of the amount of poison oak, because I wanted to get it out. It was everywhere, which I've not really captured before. It was like growing on the sand. So you can see how light colored these, like super pale green. They also don't show up in photos that are taken higher up because the sand is so bright, they tend to wink out. It's like when a bug flies in front of a light bulb, how you can't see it because there's too much light behind it. Same thing happens here with the sand, that on a bright day, the sand reflects so much light that these plants actually wink out. You can't see them. They just disappear, which is kind of probably what's happening. So some examples of why I chose the tool I chose is because you cannot see these plants with any other system. It's got to be low altitude. And this is actually a particularly bad picture. The camera was set to take really low resolution pictures. So we can't use this for research purposes. It's not a good enough scale to do that, but can't stitch them. The stitched scene, because it has to resample, it's really pixelated, but it's still interesting to look at because they're more current. Yeah, so all of these parameters that are unique to my system, the fact that I'm looking at tiny things, the fact that I'm working on a windy system too, like beaches are super windy. So kites are great when it's windy. I will tell you, hot air balloons are not great when it's windy. Did that originally. They tend to blow around. They tend to light on fire because the wind blows the envelope into the fire that keeps it afloat. So definitely not the way to go there. Also, helium balloons are not a good idea because of the cost of helium shortage. So that kind of limits you to your kites, and drones. Again, restricted, and they're really bad for the endangered species that tend to live on California coast. Even though like there's say plovers are afraid of kites, I've not actually seen that. On this beach, there was a single plover running around on the water line. He did not move. He did not care. He was doing his plover thing. Didn't disturb any of the shorebirds that were busy to have the kite up in the air. They cared about us people getting close to them, but the kite flying in the air did not seem to bother the shorebirds whatsoever at this particular site. And there wasn't any nesting. So that's just an example of why you want to use a given system to meet the needs of your research question. So for this better quality imagery, we can pick out individual plants. I can understand what's with this spacing. Why Are they far apart? Like, is there some kind of system going on here? These are similar color, but these are different species. See how they trail and things like that. How are they interacting? We can build with better imagery. We can build 3D models and understand what species are on what elevation of sand. And we can see how that changes distance, which is a proxy for time on beaches. So closer to the water line is typically newer than things further down. So we can use all of that kind of properties of the photos to help us understand all of those kinds of questions. Like you'll see on, I know it's probably hard to see in the room, but like each of these little probably has a particular species on it, depending on how close it is to the high water line, and it's doing things that will then eventually get species to move in. Bigger helps with this guy with more sand. So I quick intro to beach plants with a photo. I think now we can switch over. Liam, do you want to there?
I can plug in.
Yeah. So we'll folks online sit tight. We're going to do some computer switching and Zoom resharing, and then new example.
Okay, hi everyone, I'm Liam. I am just going to talk through a little bit about sort of my experience with field work using drone imagery, photogrammetry, and I'm going to show a couple of examples from my field season this winter time, and just talk about like the different things that can happen when you are out in the field and things that you need to consider that you don't think you might ever need to consider. So think of it sort of like a tips and I don't want to say horror stories, but real world examples of what can go wrong. Lessons learned. Thank you. Lessons learned.
Section tips and horror stories. Yeah, I like that.
So if anyone has any questions at any point, feel free to ask in the chat or unmute and answer them. It's meant to be a little bit more Q&A if you guys have. So we go through this. I had put together a pre-questions slide to ask, but Michele already covered that, so I'll just kind of skip over this. And so one of the first things that you want to think about, so at this point, you've decided that you want to do photogrammetry, you've decided on what system you want to use, and you're thinking about planning your first mission going out, and you're super excited, you have all your new equipment, everything works, you charge your batteries, and you want to go out into the field and capture your first imagery. These are things that you should think about. One of the big things for me is just how much help do you need? And as a graduate student, sometimes it's really tough to get other people to come help you because you don't have funds to pay people. You're maybe going at inopportune times. So how do you actually, get help? Because one of the things that you'll realize is in the area that you're working with, like where you're going, it's always helpful to just have another pair of hands to help you and someone else to sanity check you when you're out there to make sure you're doing everything that you're supposed to be doing. So if you're a graduate student at UC Davis or you're planning research, consider trying to take on some interns. If you have the funding for it, always great to pay interns for their help. But also undergrads are, they want to get their experience and they want to get hands-on experience, and maybe your lab members can come and help. Always ask for someone to come help with you because you always just need a second pair of hands. The thing I've learned is checklist. I can't say it more than once. Like you have all the gear that you need to go out in the field and you think you'll remember it all, will not. You will forget, and that's okay. We're human, we're always gonna forget. Laminate the document so if it rains and it gets wet, it won't get destroyed, but have that checklist such that when you're packed up the car and you're ready to go, triple checking that checklist, your intern's also looking at that checklist, and you guys make sure you know what you have. Third thing, water and snacks. When you're flying the drone, flying the kite, you're looking for ideal conditions, clear weather, no clouds. It's going to be sunny. You're going to be out in the field. You're driving a long distance to get there, or even a close distance, but you'll be spending a lot of time in the field, and people underestimate how quickly it is to feel exhausted out there. It's helpful to have water breaks, snack breaks. Think about it. You're out there doing work. It may not feel like work because the drone is flying, taking imagery, and you're just sort of standing there looking at it and looking at the computer. But mental exhaustion is a real thing, and it's very helpful to have water, snacks. One thing that I've done this field season is when I'm in the field and something goes wrong or something didn't go as exactly as I planned, or I changed something on the fly, and I'll show you an example of that, document it. So one of my project involves taking sort of samples on the ground as we fly, so sort of ground truthing samples. I had the bags where I collected my samples. I recorded samples, numbers, names, and our measurements, documented it on the bag, on my phone, and my intern also documented it on her phone. So we have 3 copies of what that looks like. So if anything happens, there's always a backup copy. Also, if things change in the field and you had to make a simple correction or you did something differently, write it down as soon as you can, because you will forget that detail. Everyone always thinks that, I'm so excited, I'm gonna go home and process this imagery as soon as I can. You're not going to. It's gonna sit on the computer, and then in a couple weeks you'll look at it and you'll be looking at the imagery and you'll be like, why is this different than what I initially had planned for? And you're gonna forget that little detail. So just try your best to document everything, even if it feels very minuscule. Like that sort of self-check and getting yourself in that frame of mind where you're always trying to ask questions and document things is going to be helpful later on. We have a question?
Sounds fluctuating.
Oh, change the,
Yeah, I changed the.
how about on his computer, not on the field.
Yeah, if anyone in the chat wants me to repeat something but you can't hear it, just let me know. I'll repeat. So what was that? Okay, right. And so you've done all of that and you're ready to go out, check your weather conditions. This California rainy winter season has been crazy. It's been a lot more precipitation, a lot more windy. Each drone, each sort of photogrammetry system is going to have their own optimal conditions. So it's helpful to keep check of that. Even if the forecast looks good the next, or check it out you go into the field. You don't want to waste time if you know conditions are going to be bad. So just be on top of monitoring the weather. If you're also doing field sampling and you're not just taking images, think about what you want to do to create a methodology to help you save as much time in the field of if you're going to geotag all your sort of sampling locations beforehand, then you fly and then you leave. Think about like how you want to organize your workflow once you're out in the field of what will be the most optimal conditions. So for example, for me, yesterday I drove down to Fresno, got there earlier before it was sort of solar noon where we wanted to fly. So before that, we went and tagged all the locations we wanted to sample. Then we flew, and then after we flew, we went and got all our samples. So even though that there was that downtime from like maybe 10 a.m. to 12 p.m. before we can fly, we still tried to make use of that time. And then think about what your field area is. And this kind of ties back into your research question of, are you doing ag research, urban environment, grassland, like sort of the requirements for photogrammetry, and Michele sort of touched upon this, like when you're creating your flight path of how much overlap you want between the images, it's going to depend on what your environment is. So for example, for me, and I'm working in tree canopies, if it's particularly windy on a day, you can imagine a tree canopy is going to be blowing back and forth. And so I might want a little bit more overlap in my images on that specific day to help sort of correct for the fact that that canopy is moving a bunch during that actual flight. If you're in a grassland, maybe it wouldn't matter as much. And then maybe if you're in an urban environment, your buildings are not going to change. That's pretty static. That maybe might not matter as much, but try to have these thoughts in your mind about like what your field area is going to look like before you get out there. And then this is sort of like my mantra of just like how fieldwork has gone for me in general. Something will go wrong at some point. It will, and that's okay. You just need to learn how to plan and adapt and have backup solutions. And limitations are okay. I think that's when we get excited about research, always excited about research. We want things to be as perfect as possible. That's not practical at all. And so there are going to be limitations on your work, and that's just a natural part of research. And You just have to account for it. And so I just kind of want to share a couple of examples. And oh, this was a quick thing. If you're part of the UC system, and specifically maybe UC Davis as well, if you do go down the route of drone photogrammetry, you have to register your aircraft with UC Davis and get your flight approved. This is sort of a website that will take you through that process and what it looks like. And that's just for insurance purposes for you if there is an accident with the drone, and also for the university. So that's something to keep in mind that this is something that you're going to have to get approved before you get your flight. So there is that additional like documentation and paperwork that you need to do before. So it's always good to plan ahead. So my field season was January to sort of March. All this planning started in maybe October, November, probably honestly even September. So it's helpful to think about these things beforehand. So my general question is sort of like, I look at almond orchards and sort of the crops that they plant in between rows of trees. And I'm trying to see sort of species level differences between what type of crops they plant, right? And what we wanted to ask was, can drone imagery help identify different types of cover crops in this case, and then also sort of track the biomass differences. And so recognizing that, we want to create multiple flights, so take multiple images at different times to sort of create that time series of how that plant vegetation growth might change over time. And so here I want to just describe like one of the field stories I had. So this orchard is pretty close to UC Davis. So the orchard is in this white box over here. And then if you're not part of UC Davis, we have like our own little airport. I think it's called Flying Farmers or Flying Aggies. And it's right on this side. And so our orchard is pretty close to the airport itself. And so even before registering my flight and getting it approved, we had limitations on how high we could fly because we were close to the airport. And I had to drop off a notice letting them know when I would fly, etc. So it was this season, very rainy winter, very few clear consecutive days to image and then also go out and do the biomass sampling. Finally got one weekend. This was like maybe 2 weekends ago. We went out on the Friday. It was way too windy to fly. It was maybe like 11 miles per hour on the ground, which is like not great, but okay. But it was gusting up to 26 miles per hour once you got up in altitude. And you never want to take the risk. So we didn't take the risk. Second day, we went out Saturday. So this sort of magenta arrow was where the wind direction is. It was kind of going blowing north to south. And so the planes from the airport were actually taking off on the runway and transitioning their altitude right over our orchard. And so normally, technically, legally, they're not allowed to fly over the Hutchinson Road here, but because of how the wind was blowing and to get up to the altitude they needed, they just crossed over here for like maybe 30 seconds. But flights were happening like every 15 minutes. It was like one of the first sunny Saturdays, so everyone was just trying to fly and get their hours in. And so we couldn't fly. It was like every 15-minute period we saw another plane coming up. And it's one of those situations where you've been so stressed to try and get data for your season, and you have this obstacle. It's like, do you risk it? Most definitely not. And that's just some of the limitations that you have to deal with. Luckily enough, we went back on Sunday. It was a good day, able to capture some imagery. And this is sort of what one of the images looked like. So this is sort of an RGB image. We flew with a multispectral camera. And so this is sort of like an RGB image here. You see sort of the orchard in bloom. And then these are sort of the cover crops growing in between. And so what I want to point out here is that this orchard is actually like a north-south orientation where the trees are. So what we tried to do was fly at noon to sort of minimize the shadow, because what we're interested in is this grass in between the different trees. And so we're minimizing the shadow to be directly sort of above the tree. So it's a little bit smaller and the shadows don't cast on the rows themselves. And so I'm pointing that out because the orchard I went to yesterday was actually east-west orientation, which was very odd. And I didn't consider it when I went down there. And this was short notice again, because of how our season is gone. And so we went down to go check out this orchard and we flew. And so here I want to point out that our row orientation for our trees are now east to west. So there was actually at no point where, even if we flew at solar noon, the shadow was always going to be casting on these rows. And so when we were setting up our sampling locations, so when I say sampling locations, meaning like where in the rows of the little grasses we're going to take our biomass samples, normally what we would do is sort of walk our way to one of the center of the tree. So let me go back. Walk our way to center of the tree, walk in, like maybe measure out like 3 feet into the row, and then take that biomass sample, which this imagery here, after it's rectified, you still get a pretty clear picture. But here, because of the shadows, that's not necessarily the case. And so we sort of change the sampling locations on the fly to be in between trees to, capture as much unshadowed vegetation as we could. But again, it's just one of those things of we didn't really know what the orientation would have played such a huge factor. And when we got to the field, we had to make that sort of decision on the fly. And then I just kind of want to point out, like, this here is this black and white square is my GCP that I've put down. So when I'm correcting the imagery later, I know I've geotagged this location. I know what this actual GPS is. I've located it here, right here, to a known object as well. This is just like a huge pole that was also here. And so, it's helpful to use markers in the field, stuff that you can remember when you're looking back in the imagery to know, like, hey, I remember where this was. And so it's not all doom and gloom, like I'm probably making it seem, but just limitations that happen that you don't necessarily think to consider beforehand, that when you're in the field and you're thinking about stuff, you just have to make changes on the fly. And I think, yeah, that's sort of all I wanted to go through. I was hoping I could show sort of what the app is that we use to do our flight planning, but my laptop's does not want to connect, so I can't log into it. But yeah, I guess we can open it up for questions if anyone has any questions on Zoom, in the office. Yeah. Sure. Yeah, Naomi.
Do you have a minute to talk about what orthorectification is? You both mentioned it in terms of like this level of it.
Yeah.
Is there someone who totally knows what it is but maybe forgot?
So this picture that Liam has up is a really good example of what is not orthorectified. So if you look at that pole that he mentioned, see how it leans? Like, for people in the room, if you want to come up and like actually get close, you can see this pole, you can see the side of it, even though you're taking a photo looking down, because it's not the center of the photo, it's like it's leaning away. Orthorectification takes that lean out of the objects. It makes everything look, and if you're on the edge of the photo, it makes it look like you're looking straight down. So it takes that, we call parallax, it takes that lean from the edges out of the photos. It makes every part of the photo look like the center of a raw photo. So that can be really helpful if you're trying to avoid things like, I wanted to say where this pole is, like I bring this image into a GIS. The location of the pole is not the top of the pole, it's the bottom in the image. But it can have photos that move that problem for me. Process of rectification.
Yeah. Thank you, Michelle. And then we have a question on Zoom. Charlie's asking, can we say more about GCP usage? How many? And then accuracy compared to picking existing features.
Yeah.
I can talk about that. I think it depends on your area that you're interested in. Normally, when I'm creating sort of an area to fly, it's normally a square. So I had minimum 4 GCPs. So these sort of black and white squares. The reason why we like those is because they're super visible in the imagery. It's a regular shape, and the middle is right at the intersection of all those triangles. So you can think I put one of these at each corner of my huge bounding block of where I flew. So that's sort of like a helpful place to kind of go from. I think if your shape is irregular, if your area is a little bit wonky, like maybe you want to put a couple more GCPs down. If you're working in sort of a grassland area where there aren't many definitive features on the ground itself, and maybe with the beach is a good example, you might want more GCPs. That might be helpful. So again, it depends on kind of like what the area that you're working in is. And then in terms of like picking existing features that already are going to be in your imagery, I would recommend not always relying on that and maybe more using that as like visual backups. But in my case, like these irrigation lines that you see in this image here are pretty static and those are not going to move. Like that's a good indicator to know where you are. That pole I was looking at, there was one huge dead tree on the side that this image doesn't show, but I also took the GCP of that just in case because it had been there for a very long time. So regular features, like man-made features that you think that are not going to be moving over time, especially if your goal is to create sort of a time series of images and you're tracking stuff over time, stuff that basically won't change. I don't know if that makes sense.
Yeah, and you don't get that on beaches. It moves constantly. Like it's literally washing away right now.
Right.
And then later it will build back up and it will change. So count on anything on a beach staying where it is. So I also have GCPs that we can take out. Mine are fabric. I actually, my blog has instructions for how to make these things. But if you're gonna make your own, pro tip, take your sensors to the fabric store with you and take pictures of fabric, because some fabric combinations, like Liam's example here, black and white, super good contrast and visible, might not work in IR.
Exactly.
So like I was in Joann's Fabrics with the ripstop nylon and ribbon combinations, taking pictures with the IR camera to see if there's contrast, because there was some white ribbons on the black fabric that you could not see the difference in infrared. So my infrared photos could not be georeferenced if we didn't make sure there was contrast in both camera systems. So that got a lot of questions from the folks that were staff at Joann's that day.
Yeah, sometimes you have to be creative in your problem solving.
Yeah,
Most definitely.
I think that's one thing people overlook when they're doing their own collection with drones and kites and stuff like that, is that level of creativity and engineering you need to do this well is well above like just downloading satellite imagery. Like there's so much problem solving that goes into this. Like you said, in the field, you have to be willing to shift your sampling and you know, suddenly a camera stops working, or you know, like you left something at the car and have a quarter mile to walk on the sandy beach. Do you really want to go get that thing? Like it's going to take you an hour to go get it. So you know.
Yeah, I guess as a funny thing, yesterday when I had booked a car from UC Davis to go down to Fresno, but when I woke up at 4 a.m. to go pick up the car, my own car died. So I had to bike to go pick up the car, then go pick up all the equipment. And you know, that delayed us, but you know, I had built in like a buffer window there. But you know, maybe I've just had a lot of bad luck this season, but those are things that you want to think about. And I guess one thing I'd want to emphasize is, if you can, before you go out and take imagery that you hope to analyze, try and do a test flight. Try and go scout out your area, do a test flight so that you can identify, one, get familiarity with the area that you're working in, and just see what the constraints are from the beginning with a data set that you don't necessarily need for your analysis. And I think that's always going to be helpful. It may not always be the ideal case that you can do that all the time, but I would say that's always a great starting point.
So true. You learn so much about how to work with your team and things like that. And these things have a learning curve too. It's not like you just take the drone out of the box and say, go. Like it really, there are skills you must learn to use these things, and kites the same. Like you are physically, like exhaustion is the real thing with kites, because you have this kite that's literally pulling like 10 pounds of pull on the line and you are holding it the whole time. And if you want to move that thing, you have to move your body. It's not like a drone where you program the flight path. Like with a kite, you're physically moving it and pulling it against the wind. And that's another thing too. Like wind sounds great when you have a kite, but gusty winds are death to kites. Will make it. Sometimes I have one that will flip in the air and dive on the ground if it's gusts.
Yeah.
So, you know, you have to know your weather if you're going to be going out and doing field work with these things.
Your kite, like, did you make it yourself, or did
No.
you bought it with? Okay.
Yeah, so kites are really hard to balance on your own. Like I buy them from a company called Into the Wind that's from Colorado. They make their own in-house, but they're pros. I have a couple different kite systems, but it's definitely not something you want to make yourself unless you're really into kites. So, they're pretty cost effective compared to drones. It's a lot cheaper, but it is a lot more creativity because you have to build pretty much everything. Like you can't really buy a commercial system for kite aerial photography.
Yeah, and I guess one thing I wanted to also say is, you know, after you've done all the collection, a huge part of this process is processing that imagery, which we didn't spend a lot of time on today. And I think one thing to point out is there are a bunch of different commercial and open source software to help you process imagery. They all have their issues. Some of them are good at some systems, some camera systems work with some applications. And so, you know, try not to get, at least from my experience, try not to get bogged down on using, you know, the most expensive photogrammetry software and just like buying that straight out of the box and buying a license for it because they're expensive. And in my experience, like most of the time, a lot of the help is typing it in and adding Reddit and then seeing what other users have changed their settings to make the imagery stitch and align better. And, you know, really going in the forums and just asking other users. Sometimes the support systems from the official companies aren't super great. And so I think that's a frustration that you'll have to deal with. And thinking about, you know, if you want to do open source or, you know, buy a license for a program, they're normally education licenses, which will be cheaper, but they're always trying to sell a product as well. So something to keep in mind.
Yeah. And like I like Open Drone Map, it's open source, but if you want the free version of that, you can pay to have the version and just run the exe on your computer. But if you're going to build it yourself for free, you have to use Docker and things like that. So there's a bit of a learning curve setting that up. It's not insurmountable, but it's not as simple as like just get the file in, install it, done. It takes a little bit of time, and it's well documented, but you know, something to consider. You could pay for the compiler version, be done with it for yourself.
I see Charlie has a question. If I had a series of images of an almond orchard taken every week during growing season, could I register images well enough to measure branch length growth? That's an interesting question. I think one thing I would think about is what the age of the orchard is. Maybe if you're doing like a younger orchard, that branch length growth might be more visible. I would think maybe LiDAR would be maybe a little bit better because you would be able to sort of characterize what that canopy looks like at the beginning of the season, and then at the end of the season, that canopy would look different. And LiDAR, if you're not familiar, will sort of capture sort of all those different branches from the top to the middle to like the bottom of the tree a little bit better than the optical imagery that I'm showing here. That's only capturing sort of the reflectance and not necessarily the 3D structure. Yeah, I'm not aware of any research that necessarily does that, but there is someone at UC Davis who I think he drives through orchards with sensors attached to like a little vehicle that shines light upwards, and so it captures sort of the light going. Well, it captures the light kind of coming through the canopy, and you know that might be, you know, a different sort of remote sensing that's not necessarily drone based, but just a different angle at it. Yeah, I don't know, Michelle, if you have any idea.
Yeah, I think it's good to think about like what sensor is going to give you the data you need, and that I think that's a good illustration of why you need to start with the question like Charlie has, and start thinking about like what's the most appropriate data collection method. So I think one of the challenges, like looking at the images that Liam has, is that the way trees grow, like they kind of, because they're close together, they grow and then they stop when they get close to each other. So when you remove a tree, you see like, why is the tree doing this? And it's because the other tree went like that. So I think trying to figure out like what's the best way to capture the data that you.
Yeah.
And I think, you know, canopy width in an orchard isn't going to necessarily help because of that compact way that we build orchards to maximize, you know, space. So you know, you might not be able to actually see that on all the trees. It might just be the ones on the edge, you know. So you really want to think about that system, like what are you actually going to be measuring? And is that something that you can get from this kind of data set? And, LiDAR is potentially useful and you can put that on a drone, but we will get the structure that the LiDAR bounces off of, so you won't get the lower, like at the top. So like there are limitations of all of these different systems and data collection methods. So, I think it's a really interesting question. And if literature review time, if nobody else has done it, it might be worth exploring. I don't know. That's a tricky one.
So maybe more for William and Michelle, because I'm curious about drones. What drone?
So the question in the room is what drone have I've been using, and so we've been using sort of this system in the bottom right of this photo. It's called the EBX platform. It's different than maybe what the traditional drone looks like, which is like a quadcopter. And so one reason why we're using the EB is because one, our DJI system quadcopter broke, but also because the Department of Defense in the US, and there was a presentation on this the other day, has sort of blacklisted DJI. And so they're set to be discontinued in research. I think it's supposed to end by 2024. So because of that, we moved to a US based platform, which is this EBX, which is officially approved. And so again, that's another limitation of DJI is a huge platform in terms of people making drones commercially at cheaper prices for any sort of use. But if you're using federal funds and you're in the UC system, that's something to consider. And if you have questions about that, you can give me a message and I can put you in the contact with the person who you would ask about that. But one of the benefits of this sort of fixed wing platform is that it can travel longer distances, which is why we kind of wanted to use it. And the camera system that we have is a dual RGB camera and a multispectral camera. And so it's capturing two images at the same time. That RGB image I showed, and also a spectral image in respective wavelengths. And that sort of co-capture helps with image stitching and registration, in that you have like 6 images at every single position, and that will help you build a stronger final image after you're stitching it together at the end. And that was sort of the benefit with this.
And then the second question is, and I don't think it'll apply to either one of you, but I'll ask anyway because of the landscape you seem to be working in. So the simple question is, let's say you're working in an area that's got some pretty rolling topography associated with it. Have either of you incorporated, let's say, a DEM into your flight planning process to keep your platform and your sensors at the same elevation above ground through the life of the entire mission? You guys are probably flying in flat ground where that's not a problem, but I'm having to think about, in the case of my work, where you may have some very steep topography and you want to keep that platform the same height above. So I've heard or read that you can incorporate, let's say, a DEM into the flight planning software to do that. But have either of you got experience doing
that? Alex, do you have experience with that?
I did research that a bunch. There's a research lab here. Derek Young works in forests in the Sierras. He has a lot of experience with that. The biggest problem with the DEM based is that the resolution of the DEMs is not that good sometimes. And some flight planners don't have that precision. So it may limit which flight planners you use, because not all of them let you do it.
Okay. Oh, if it's okay, I'll get back in touch with you.
20 minutes.
Well, also, since you switched platforms because your one did not work, I will mention I started doing balloon aerial photography because I got a NASA space grant to work with Susan Houston's fixed wing aircraft, and then they crashed theirs, so I had to find a new system. So sometimes it's a blessing in disguise, and you suddenly have to switch systems, platform, and something new. Yeah. Kites work great on I don't think the fixed wing would have liked being on a beach, so.
Yeah. I don't think so. Does anyone have any other questions online?
Your favorite field snack?
My favorite field snack? Oh, peanut butter pretzels, for sure.
That's a good one.
Yeah.
Yeah, you should also tailor your field snacks to your location because nothing sticky goes on pizza.
Oh, yeah.
Nothing sticky. Sand blowing everywhere. The peanut butter pretzels are also good on.
That's, any other questions?
Add also bring sunscreen and hats. Like,
Oh, yeah.
the bucket hats look stupid, but they're great when you're out in the sun. So. We actually keep, I keep my equipment in a big like plastic Tupperware thing. And we actually keep extra hats in there just in case, because that's one of the things you cannot be without when you're out in the field and like you're spending a lot of time looking at the sky. You need hats. So we have like all the ridiculous hats that, you know, no one wears normally. Like there's always a couple in, because you can't not have that. Like you also need sunglasses. Like that all sounds very superficial. Like it's not for fashion, it's because it's protective gear. So it's just something to keep in mind. Like you want to protect yourself as well as your equipment.
I guess maybe the final thing I'd say is that if you're in the UC system, and you're doing drone stuff, you probably have seen like the 107 license for like small UAVs. I think the official position is if it's for research, and I think this sort of information kind of changes on a yearly basis. I think the official position is that you don't necessarily need to have the license if you're doing research. That being said, I got the license. It wasn't a terribly difficult process. And I would always recommend it because it gives you added experience, and you learn a bunch of cool stuff. So I would just always check in with your research supervisor, your advisor, and whoever you're working with of like getting that specific yes or no of like if you need to get the 107 license or not.
Yeah. And there's an office and like within the UC that can help
Yeah.
answer those questions. It's based in UC Merced, but they can
Yeah,
answer
Brandon
questions.
Stark.
Yeah. Really good resource for understanding what the current requirements are. I think also like one of the advantages of licensing is you learn about the regulations that you have to follow anyway.
Yeah.
So you might as well, know what you're being held to, because like they're not just to make your life annoying, it's literally for safety of human lives. Like I know it seems like it's a kite or it's a drone, it's a fun thing, and it totally is, and like they seem inconsequential because they're only this big, how much harm can it do? But like we're talking about literally accidentally breaking down a craft if
Yeah.
you do this wrong. Like there's still harm that can happen if you don't follow the regulations, like to yourself and to other people. So you definitely want to know what those are. I think it's worth, if you're going to fly drones, to do the licensing, just to know, how to do this safely and properly. It's not something to take lightly. It's a big responsibility.
Permission wise, do you also need to get permission from like the orchid?
Yeah, and so any field site that's a good question in terms of depending on where your field site is, like what sort of permission you need. In my experience, my research sites have been through UC Davis and UC A&R. So talking to the people managing the field and giving them an idea of what our work is, when we'll fly, and what responsibilities we'll have, and if we need any help from them. Normally when I'm going out to the field, I don't like to ask other people for labor because they're already doing other things. That's why I say I go with my interns and whoever can come help. I think maybe if you're in BLM land or US Forest Service land, like national park stuff, all those different agencies will have different regulations when it comes to if you can fly, what are the proper channels. So it's, again, if your field season is in the summer, it's good to start thinking about those things from the fall from before, so that you are contacting the right people and getting the official permissions, and just knowing more about the area that you're working I don't know if beach regulations.
Yeah, when you're flying a kite, you fall into different sets of regulations. So if kite flying is allowed on the beach, you can do that. But in terms of research, if I'm going to be flying for research purposes, you do need to get permission for, and mostly it's they just want what's going on. If you're working on state park property or national park property, there's a permitting process. We'll say the last time I emailed state parks about doing research, they never got back to me. So there's that. But do your due diligence on that. Like, do the application if they don't get back to you and you're not really going to be doing any harm, anything beyond like what a normal visitor would be doing, you're probably covered. But I would say it's good to get in contact with them, mainly also because the people who do there want to know what's going on, and also you get an opportunity to network, and maybe your research, like you can give them the imagery and then they can use it, or they can provide input. I think it's definitely worth talking to folks, manage those places. And certainly if you're going to be flying over private property, that's a whole nother situation. You should get permission for that. You don't just fly, even though the kite is tethered, like you don't just fly it over somebody's property. Like you would need permission for that. Be a good human.
Yeah, exactly. I think that's a good rule to off of, and I would just add that, with the increase in like drones and different forms of remote sensing and like privacy issues associated with that this sort of regulations is constantly changing from a year to year basis. So it's helpful to just keep abreast of like what are the actual responsibilities that you have. That information will sort of be channeled through like the university, for example. Every year, I check in with Brandon Stark to ask him, are there any changes or anything like that? But yeah, it's very topical right now. See stuff, so good thing to keep in
It
mind.
continues to be an issue.
Yeah.
Any other questions?
Thanks for stepping up on short notice.
Literally met on Wednesday to
Wednesday?
figure out how. I was like, all right.